considerations. The table must have a clustered index, which is a B tree or heap. Currently, you cannot have a clustered column store index. That's something that the Microsoft SQL Server team is looking at for future releases, but as it currently stands, the column store has to be the secondary index. And as I mentioned earlier, once you apply the column store index, the table will become read-only. You will not be able to insert new records into that. So you would potentially have to drop the index, recreate the index once you've loaded the data, or implement some sort of partitioning logic. You can only have one column store index per table, and they must be partitioned aligned. So if you've got a partitioned table, you must have a partitioned index as well. You cannot have a column store index on index views, and they cannot be filtered index. So just some best practices to keep in mind. So in terms of best practice for indexing or creating the index, include every column in the fact table to be safe. It's not necessary for you to restrict yourself to a handful of columns. I think add all of your columns to that index. It will handle it very well. Try and overcome some of the restrictions that we've talked about by modifying the data types. You know, if you few examples there, that way you can convert maybe GUID to a big int, or changing the numeric from 38 down to 18. So these are some of the things that you should try and implement to get the best. Well, first of all, to be able to use the column store index and get the best out of that. And as I mentioned earlier, it's not necessary to have column store indexes in dimensions, but in some cases we can see it adding some value. Best practices for loading data into a table with column store indexes. So in my view, if you are updating data on a daily, weekly or monthly basis, it would typically make sense to have column store indexes. If you're updating near real time, there are ways around it, but again, typically wouldn't necessarily be recommended. You're looking for, typical data warehouse, nightly, weekly, monthly loads. That's where it makes probably the most amount of sense at this stage in this build and version. You can implement some sort of partition switching. So you populate new data into a new partition to get around the whole dropping the index and recreating the index, if you like. Typically, each partition should aim to have more than 1 million rows per partition to get the best out of it, because there is some overhead in the querying. So if your partitions are a lot smaller, then that additional overhead could have a counterproductive result on your querying times. And as I said, for real-time load requirements, there's a combination that you can do. You can have query on a column store table, and then you can store the data that's just come in on a separate Delta table. So there's a way around it, but again, maybe not quite ready yet. Best practices for querying. The sweet spot, as I mentioned, is for inner join or star join queries when you're grouping and aggregating data. That's where you really will see the benefit of column store indexes. Avoid unions, outer joins, not-ins, and string filters on fact table. These are all likely to have, will all likely cause execution to not be in batch mode and revert back to row mode instead. Okay, so it's 35 minutes. Hopefully you're still with me, haven't fallen asleep yet. Okay, so I think I need another 10-15 more minutes, hopefully not eating too much into your lunch break, to go over or give you an overview of the business intelligence semantic model. So the business intelligence semantic model, or BISM, is one of the most powerful new features within the SQL Server 2012 delivery from an end user reporting perspective. The BI semantic model powers all of the Microsoft front-end experiences like Excel, reporting services, SharePoint Insights, and other features such as Power Pivot that you're aware of. Some of you may be aware of. It comprises of 3 layers: the data access layer that integrates data from various sources, relational databases, business applications, the Azure marketplace. You've got the business logic layer that encapsulates the intelligence in the model, and the data model layer that is exposed to the client applications. So we'll try and look at these 3 layers in a bit more detail in the next few slides. So how to BISM? I'm not going to say BISM. So what tools would you typically use to build your model? So you've got Business Intelligence Development Studio that comes with Visual Studio 2010. That is a requirement. You can't build a tabular projects in the 2008 version. You need Visual Studio 2010. The end user tools, you can expect Excel, Power Pivot, and Crescent to play a quite predominant role in terms of accessing data from this model. And you've got the additional capabilities. You can still create hierarchies, KPIs, perspectives. You've got a new querying language known as DAX, which is very similar to those familiar with Excel formulas to create calculated columns and measures and so on. You can also write DAX queries as well. So whereas before you had to learn MDX, if you built a tabular model, you were able to write DAX queries on top, and if you're, like I mentioned earlier, if you're familiar with Excel formulas, you'll be able to pick that up a lot quicker than MDX, I can assure you. Some of the performance and scalability benefits or enhancements that have been made. You've got the MOLAP dimension scale, so you can now have dimensions which can store strings that go beyond 4 gigs. I think this was one of the features of 2008 R2 and previous versions, where if you had a very large dimension and a string attribute, the amount of data that it could store was up to a limit of 4 gig. But this has now overcome that issue. You've got the Vertipack performance, which we'll be talking about. I mentioned it earlier with regards to column store indexes. So this is the in-memory, highly compressed data for rapid querying performance. And you've got the equivalent to rollup querying via this feature called direct query, which sits on top of tabular models to query data relationally rather than bringing the information all into in-memory. So I mentioned the 3 layers earlier, so let's look at those in a bit more detail. So the data model layer. So what we've got here is sort of a contrast and compare. What do you get with the tabular model and what do you get with the multidimensional model? So you're all familiar with the multidimensional model. That's your existing MOLAP, OLAP structures. So you're all probably quite familiar that it's a very sophisticated model. There's a higher learning curve because you have to learn this whole new technology. You have to learn this new programming language. Lots of configuration and properties and things that you can do. The tabular model aims to be a lot more simpler and easier to build. So therefore, what you can see is that the advanced features, most of the advanced features have remained in the multidimensional model, and what they've done is they've brought across sort of the fundamental features that you'll need into the tabular model. So that's what the second bullet point is trying to highlight, that in the tabular model, advanced features such as parent-child and many-to-manys aren't available natively, although you can build in that type of behavior via calculations, whereas that's available out of the box in the multidimensional model. It's very easy to build a tabular model on top of a database or a warehouse and then fire up any reporting on top of that. So those familiar with the Power Pivot feature that you got with Office 2010 will immediately appreciate that particular point, because with Power Pivot you were able to pull in data from all sorts of different source systems and build that model. So it's very similar now. You now can do this in Visual Studio to build that model. The business logic layer. So there's 2 programming languages now available to you. So there's MVX, which is, to be fair, quite complex and quite complicated. Those people with a SQL background, it's always a very high initial learning curve to get your head around what MVX is trying to say. Whereas DAX is based on Excel formulas and relational concepts. So it's a lot easier to get going and to understand. There's advanced features in both programming languages, both querying languages. Under different scenarios, the learning curve will be far greater. So in DAX, when you're applying filters and calculations, there's a bit to learn there. I'm sure basic calculations is fairly straightforward, but anything complex, you'll need to understand the syntax. And similarly with MVX as well. So in different scenarios, the learning curve is different.